Exercise 51 solution, 51B. All right, so you need some help. No problem. Everybody needs help. You should have given yourself the best possible chance you can, really plugged away at it. Stop the video if you ever run into a and you get the aha moment. Stop the video, right? All right, so I'm going to show you how I solved the problem of storing the statistics to disk. I had these security requirements. I wanted to use real paths or some kind of encryption, some hashing. So realpath, let me just show you, and it has its own issues. And you'll see when I was doing it, realpath, it has some interesting things that make it not as useful as you would think it is. For example, the file has to already exist. So you can't get a real path to a file reliably that you want to create. Now, it still makes the real path, it still solves it, but there's some problems. So I had to work around that. You'll see in the video, I actually make that mistake, and I just go with the encryption only. I also use some bad encryption just to kind of show you it's a little on the fun side, so you can see. But also I wanted something to critique in exercise 52, so I added some bad stuff. And then there's no other security beyond that. Okay, what did I use for the encryption? I used an algorithm called XTEA. Okay. XTEA is written by some fairly famous cryptographers, and this is the entire code. So if you go to the Wikipedia page for XTEA, not triple XTEA, just XTEA, then you can actually see how that's implemented. Now, what I use it for is not the smartest thing. So again, I was using it to sort of demonstrate some stuff not to do, okay? But also XTEA is kind of fun. Don't use it for real encryption though. You'll see how I use it in the video. Okay, so the things I have to do. First, I need to make it so the commands can set path to null to indicate that they're non-recursive. Remember in the last video, I had a problem where delete was deleting everything, and that's not what anybody means. So I had to make that happen, and that's also what store and load have to do too. I finally changed the function name over to run server. I allow a third storage path argument, like an arg argument on the command line. So that way you know where the storage is, and I allow an additional argument to the command structure, so that way I have one more place to put some information for load. Okay, weirdness. My design is sort of strange because I'm forking clients, and the forks can't talk to each other. Normally you would use select, and then they can talk to each other and it'd be safe, or you would have to do lots of locking. So I got to do some things. I got to do file locks. So you can actually do man flock. That's one way. But if you do man to open, you'll see there's a X lock right there, and that opens the file atomically locked. So this will keep clients from stepping on each other. That's important because if I have the clients forked, they're running multiple processes, they'll step on each other. Storing doesn't happen automatically, only explicitly. That can be good, that can be bad. Maybe you connect and make a whole bunch of statistics engine algorithm-y stuff, and then you disconnect. Who knows? Normally, people would expect the statistics to stick around, so the forking is a really odd design decision, and I'm going to criticize that of myself in exercise 52. Loading acts as sort of a copy command, so is that good? And XTEA is not the best algorithm at all. Actually, you should be using something like MD5 or SHA-1 or SHA-256 if you want to hash these things. But it's an interesting experiment to just hack around and see how it worked. All right, so how did I do it? First, I created the store and the load handlers. Well, okay, I didn't do it in this order, but this is sort of like the things I had to do. And I bounced around, really. Okay, so I created store and load handlers. I added an arg to command. I moved the path parsing up to allow non-recursive. I sanitized location, and I created an encryption armor thing. But I did it all with testing. I did this all with unit tests, not really working them in the server. Then I worked them into the server, and then I wrote handle store and handle load. And you'll see in the video, it goes really slow. I'm just sort of like testing sanitized location, and then suddenly it all comes together at the end, which is common. I used open with exclusive lock to get exclusive locks, and close should release the lock, but it's unclear in the man page whether that's true. I only know this on OS 10 from my own experiments, so you may have to do unlock on these things. You'll have to double check that. One other thing is you'll see that this process saved me later because my encrypt armor function was wrong. I made a really stupid typo, and it caused a really big problem in Encrypt Armor. But because I had a unit test, I could throw the test in that was failing, and I could see, oh, that's what's going on. Okay, so now watch me code. Okay, so here's how I did the load and the store handlers. So the first thing I have to do is I have to go get this XT algorithm. And keep in mind, we're just using XT for fun. Okay. It's to show you that there's very little code to make XT do just about, not a good crypto, but hey, it's amazing that you can actually do some kind of encryption with it. And we're going to use it to make sure that our paths are safe. Now, at first, I kind of messed this up because I tried to use realpath plus that, but then I realized I don't need it. Okay. So now I'm going to add the store command. And notice I'm doing it manually instead of using a full replace, because remember last time on slash, I completely messed slash up. Yeah, so I'm doing it better. I'm going to have a little B string to store paths. And then I got to change the command line options so that way I can just pass in the store path. All right. So go to the stat server. And, oh yeah, and I renamed Echo Server finally. You know, I kept it around, but it didn't need to be Echo Server. It should be Run Server. And look for any other places that it's at. It's good. Next, I go to, I believe, yeah. So then once I have that, there we go. So I have to add the store path to there. And then I have to create the command line option for store path. So once I have that, then I can actually run it properly. And then once that's done, yeah, I got to make sure that's at 4 instead of 3. Then in every place that run path is called, I have to also, oh yeah, I got to update the header file and also the test and make sure the test has it too. Okay, so now I have my store path. I have to actually set that as an option. So remember, I have the setup data store up there. I can just pass that into it. And that was handy. So remember, I found that out because of a need to be able to test it. And that actually became useful right now because now I can just call that function. I know my hash map's going to get created. If I later get rid of that hash map, it's even better. Okay, you'll see I used that realpath function there to get the full path to the original store path. And if that fails, then I know that they didn't do it correctly. Okay, so store path is that, and then I have to free that path because realpath returns a path that it allocates, and I didn't pass it one. So I go look at the header file I need, standard lib, that's actually already included, so I'm good on that. Next, I believe I just have to run it and see what we got. Yes, there's one more place in the tests where I have to set it. And I'm just using temp, but sometimes that's maybe not the best. It might be better to make a directory in this local build instead of just using temp. But temp is an all right place to do these things. Okay, so once I did that, I have to add an argument to command. So that's the next thing. Oh, let me just test that this actually works. Yep, seems to run, no problem. Okay. So the next thing I have to do, I believe, yes, I have to create the handlers. So let me see if I did that. So there's the path. And that goes there. Oh, no, that's right. So I was making the path down there, but actually it needs to be done on each command because I'm going to use path being null as a way of indicating that it shouldn't bother doing recursive. So remember we had the problem with delete where I was deleting a thing, but I actually don't want to delete recursively. So, and then the paths can be processed separately or individually differently if something has to have a path because it's got slashes or a different kind of thing. So just moving it up there is a little easier. So now I can change delete to just say if the path exists, then we're good. And then I can go and set that to null. And then I can go and make parse command sort of skip anything where if the path is null, it just calls it like it did before where it was singular. And then if it's not null, it does scan path. Now this is useful because I don't want my load and store functions to work recursively. You could make them work recursively, but I prefer to not have it do it. It just seems to be too much of a pain to make them work recursively in a loop. You could do it later, but I'm not doing it. Oh, and then I'm inverting this if statement because it makes more sense to typically, you want to side with positive if statements if you can. So that way, it's like the good thing should run, then the bad thing. All right, so in theory, this should be, if I could spell recursive correctly, this should be all I need to make delete work the way it was before, but without having to compare paths. And then also, I'm going to throw this in to make sure that it should not receive a path. So that confirms that things will work correctly. And give myself an error to go to. All right, there we go. It builds. Connect. Create something. Delete it. Oops. Oh, yeah. And I had to check there because I thought parse command should always have a path, but it actually isn't necessary. Okay, so there we go. Test this again. That should all work. And wait, so now I got a new problem. What was I doing before? Handle delete. Handle delete has hash map get, and we have to go back to name because path isn't being used anymore. So this is all kind of like related to refactoring and things like that. That's, this is one thing that an IDE actually is kind of nice at, is that they do really nice tools for refactoring and altering code and molding it. So, and also discovering where code's at. That's where it really shines. When actually editing and creating stuff, I've never found an IDE to be useful. Okay, so now that we've got our sort of like beginning cleanups done, we have to move on to the next part. And that's creating some dummy stub sample holders for load and store. Because we want to be able to just sort of run these tests and have them go in the fashion that I like to do, which is you create a failing test or a failing function, write the test for it so it fails, so you know it's being run, and then go and make the function work. And this turns out to be quite a lot of work to make these functions work. Loading and storing is pretty complex, and a lot of that is because it's the way I've designed this server makes it a little hard to figure out where things are saved and how you sanitize the path. So you'll see I struggle with that a little bit in this. Okay, get my store handler going, and I get my load handler going, and then I have to just set those up like we did before. And this is, pretty much, this is kind of how it goes. Once your project is rolling, unless you run into some really bad design decisions, it's pretty much kind of, little bits of cleanup, a little refactoring, add some new features. A little bit of cleanup, a little refactoring, add some new features. Make sure your tests are working, and that makes that easier. Oh, and then notice I throw the comment in so I can remember what I'm supposed to be doing. And for the storage, I'm not using arg. I'm using arg in the load, so I can have both the path as the command name and the arg as the second option. All right, so then I have to add that in. Forgot about that. Come back. Okay, and then I do my thing. So this expects a 3 operand command, so that's good. And let me see. Yep, cool. And I just do handler. Oh, I make a mistake there. It's actually should be handler load, not handler store. Let me see if I did that right. Oh, no, I think I did that right. Okay. Okay, so this is rolling along. Now I'm just sort of like, I'm copying the test around. Remember, for the videos, I only did 2 little tests. So I'm just going to, copy those tests. But your version of this should have a lot more testing to it. So in this, I'm just making store. I'm checking store out to make sure that works. Okay, so once we have that little test going, that should be running the load in StatServe. And then I got to make sure that it runs. And does it run? Where do I see it? Create. Oh, and then my classic, I got to put the function in there. I always do that. It's a sort of a flaw in that thing I do. Okay, cool. There we go. Got the wrong output. Exists. Expected. Okay. Get exists. So now I do create, but my tests have a sort of a flaw in them too, where one test leaks into the other test. Normally, I probably should have a cleanup function that it cleans out the hash map data by like destroying it and then bring it back. But for now, I'm just, I just do a delete and then that thing works. Okay, so now store Z should fail. Cool. Just have to go and dip. There we go. 3. Get that to work. And cool. Against path Z. Yep, fixed a little spelling mistake. All right, so now I've got handle store and handle load. Okay. Now I start working on sanitizing the locations. And this is actually sort of the bulk of this video, is just going through and making it so that I can armor up a path that comes in. So I'm going to do it all in one test where I'm going to make sure that I can armor a string I'm given, get the crypto right, and then I can go and fix up the path, put it in the right spot, and do real path. But then halfway through, I sort of mess up real path, so I just get rid of it. Okay, so here I write the test. Not a big deal, really. I'm just going to make like a simple path. I'm going to call sanitize path on it. And then test that it comes back something that I can use. Oh, and then I want to add that test case that I was telling you about. So what you can see is I have this test case where I have Etsy password, but it's like, way up in a bunch of ... Now that would normally give people access to the Etsy password file. So I want to make sure right away my tests prevent that one case, which is kind of the most common case. Okay, and just sort of setting up kind of what I expect. So I can do an is equals. And actually, it's better to sort of like give it a failing case, have it come back, and then, just like copy paste out of the test output. Okay, that's good. That's good. But I'm not using that yet. All right, now I got to add the sanitize location to the header file. That's pretty easy. At this point, while you're following along, it should be you should probably just be going, this is boring. I know what he's doing. And that's good. We're getting at the end of the book, and watching me code this up is probably interesting, but me telling you I'm adding it to the header files, of course, that seems to be pretty straightforward. And it shouldn't be, it should be sort of the kind of thing where, like, at this point, you're now ready to move on, like if this is boring watching me do this and you're just doing it for clues, turn my sound off and enjoy the video. Okay, so now I'm going to implement something called encrypt armor. And this is sort of a quick hack to demonstrate something for you, but also I'm going to use exercise 52. I'm going to go through and I'm going to critique this, and I'm going to talk about the crypto and why it's not a really good idea and there's better options. But for now, I just wanted to say, hey, I'm going to use this crypto, and then what I'm going to do is I'm going to use the crypto to sanitize the paths. But I sort of kind of mess it up. Okay, so we got encrypt armor name, and these are the things that I have to do to it. Okay, that's going good. Now, I get all these comments in, but really this function changes a whole bunch. So you follow along these comments, but it's not really the useful, it's not, they change. Now that lame base 64 you'll see is a really lame base 64, but it works for now. It's not the greatest, but it's good. Okay, so now I want to do a test of encrypting an armor. So the idea is if I can make sure encrypt armor works, then I know sanitized path would work. So if sanitized path fails, I know, but encrypt armor works, I know that it's sanitized path. If encrypt armor fails, then obviously sanitized path is going to fail. So I call them in that order, and then I'm good. And this should just return encrypted variables. That's it. Or encrypted names. Now you'll notice I sort of really mess up how I call the encryption function, and it's a classic mistake. Like writing crypto code is really, you have to be very meticulous. The OpenSSL project was supposedly created by qualified cryptographers, and they have some of the worst code that has tons of security holes in it all the time. So don't ever believe people when they tell you that, they're certified cryptographers. That doesn't mean anything. That means they know some crypto and maybe they write okay code. But really, code is code. It's good or bad. You don't have to be a cryptographer to know that code is bad if it's bad. Okay, so now getting in here and making this test run. And I struggle a little bit with getting these tests to run sometimes. Because it's kind of a big context shift. C, it's really actually more common to not write tests than C. So I'm making you do it because it's a good thing. But you'll run into a lot of projects that just don't have them. Okay, so now the XT needs a pointer to two uint32 types. So one thing I have to do is I have to sort of extend strings so that way they go out to an even number. This is not the optimal way to do this, not the best crypto. Notice I typed bad crypto. Don't do that. There's actual approved ways to make sure that things are in proper block sizes or to not even use blocks. Okay, so now this is all from the documentation for XT. So keep that in mind. I'm just sort of like reading this out and writing it, but I really mess it up. And see if you can see the typo I make. All right, cool. Now you'll when you see the typo I just made, it'll floor you. It's the dumbest typo, but it is so difficult to catch. And that actually ends up being a chunk of this video, and it's very instructive for you. Okay, so the other thing that this encryption function takes from XT is a 4-element uint32 array. And I just typed in some quote-unquote random numbers. Those are not random. So I just picked a key, whatever key. Normally you would make a config file that people can actually use to set their key. So that's how you would end up doing it. Okay, now I need to do sort of like a lame base 64. So all I do is I just create a tag B string faux 64, and I put in it the alphabet and numbers. Upper and lowercase alphabet and numbers, and then I just do a modulus on the length of this set of digits or set of numbers and letters, and then just basically map it. It's the worst kind of hashing you can do. But again, I'm doing it mostly for fun to just show you that sometimes you can just get a quick hack done and have it working, but also so I can critique this in exercise 52. All right, do the lame base 64. So, if you didn't do something like this, that's cool. Like you can actually totally do the realpath process instead. But one way to make sure paths are good is to just not let paths have anything dangerous in them. So hashing is a great way to do that. Hash it, convert it to hex. Okay, so once I have this, I'm taking the character at that particular part of the data, and doing a modulus on the length of FO64, and then I'm setting it to whatever is at that part in FO64. So it works out pretty good. So, classic, I use too much Python. It's funny because when you use a lot of Python, you just sort of use the wrong quotes all the time. Any modern language, really. All right, so that's doing some crypto. But I really messed this crypto up, and it's sort of just amazing I figured this out, and you'll just, yeah, you'll laugh. Okay, it's always good to put in bug like that, and then you do searches for bug, and you go back through and you fix it. Okay, so I got that test working, and now I just got to make sure that it's the same. Copy that test up. Now, you could do what I did in the past ones where I make a function that lets me do this as many different times as I want. But honestly, I'm in a hurry to kind of get this done because I don't want to really, do this too much. All right, copy and paste it out. This is a good way to make sure you get the right answer in a lot of ways that a lot of times you can't just guess what that is ahead of time. So you can run it, and then you can find another way to confirm it. It's too bad I couldn't confirm it because it would have told me that I had my crypto wrong. So once I do that, it's all encrypting, and I try this, and then I'm like, nah. Because I'm kind of like, I don't know if that's a good idea. So I just bring it back to 1. It's just meant to be a fast hash, so that first parameter is the number of rounds, and I'm just skipping it. Okay, so now we have sanitized location. And this is where I make the mistake of trying to use realpath and the encryption that I'm working with. If I'm using encryption and it is encrypting and armoring the path, I don't need to use realpath. I just need to do a little bit of it. And realpath has a slight design flaw with it that I'll cover in a second. Okay, so I'm just setting up my comments. I got to encrypt and armor it, so I've already written that. That's pretty much a piece of cake. Then I have to combine it with the base that I've been given, which is going to be the store path variable that I was given before from the command line. Once I combine it with that using a slash, then I call realpath on it to fill up that realpath, that real character string array up at the top at line 88 right there. And that's where it falls apart. Realpath, I forgot this, or maybe I just didn't even know it, but it only really returns a valid path if the target path exists. But I'm sort of trying to do this against a file that is about to exist. So it's sort of this conundrum. I want to call realpath on something that doesn't quite exist, and realpath, it will fill in that real character array up there. But it returns an error. So I don't know if I can rely on that. So rather than try to rely on unspecified behavior in that, I'm just going to, eventually I just get rid of it. And I just go with, fine, I'll just hash the names and be done. And so I struggle with, okay, well, how am I going to do that? Don't want the attempt to be done this way. When do I get rid of things? Can I do it there? Since I just did the attempt and it's combined, so can I destroy encapath there? Do I have to destroy it later? This is sort of like a common problem with C is when do you destroy things and who owns it. A really good way to do that is make it explicit who owns what. Okay, so I'm destroying the path and I'm doing a fall through error just to make sure. Okay. And see, that's where I realized that I have this problem. The real path actually makes sure that the file is there, but the problem is I don't want the file there. I'm about to create it. So oh well, I guess it's got to go. And here I am looking at the thing. I check the errors. The function realpath will have an error if any part of the path doesn't exist. So, all right, out it goes. And this actually simplifies my code. And here I am still trying to struggle with it. Like, how do I get rid of that? And I have to think about this for a bit. I'm like, man, this is, And I'm just confirming. So I know what the problem is, but I'm just confirming. Okay, so it doesn't exist. All right. Well, I guess that's got to go. But I still sort of can't believe, there it is, that that's a feature. So, arg. And I'm armoring the file name that is being passed to me. So in theory, it can't go above what I wanted. So, all right, there we go. That means I can get rid of that. I can get rid of... And I want to have a comment there that says exactly why I don't do realpath. Because if I combine it with an encrypted armored name, I don't need to. Okay, there we go. Yeah, that's all I need to do. Simple, simple. Now I have an actual path I can play with, but you'll see I figure out that my crypto is wrong, so those paths actually have to change again. Okay, so once I'm in here, I believe I am, yeah, I have to change that up. I change it to temp, and I just toss in some junk because I'm going to actually, it'll spit out an error message, and then I can use that error message to copy paste, and I'm done. So at this point, I'm kind of like, and rather than doing this copy pasting thing, I'm going to like basically do the processing that it should to then test that I get what I expect. Okay, cool. Trying to figure out what it is I'm getting. Okay, move this test case up. Get rid of that. So at this point, I'm sort of just massaging the test to just confirm that all these different, a couple corner cases are good. I could probably go crazy with corner cases on this, but I just want to make sure that the test2 case you have there that goes to etc password doesn't go anywhere unsafe. Okay, so then I confirm that I can sanitize the location and grab those two or that whole block, fix that up. And then it's nice to just write a comment that says, hey, if you're editing this behind, I could pull this up into a function and just call this a whole bunch of times. And that's a common pattern. I'll fill in the test with code that works and it's duplicate. And then I'll go back and I'll pull it up into a function and I can run it a whole bunch more times. You saw me do that in the previous exercises where I did that for these line tests that you have there. Okay, now I'm ready to sit down and implement handle store and handle load. It seemed like a whole bunch of work just to get those paths working, but now I have the advantage. I don't have to run command lines to confirm that the path works, that encryption works, and it pays off later because I make a mistake, and because I have a test, I'm able to confirm that the mistake is gone, and it really fixes it quickly. And once I realize what the mistake is, it's super dumb, but it really helps. Okay, now I just kind of sit down and implement stuff. So I'm going to do my comments, you know, the usual. If it doesn't exist, you can't possibly store it. Makes sense. Get rid of that. Now I'm doing my comments to make sure like I know what I'm going to be doing. And this is something that I'm going to demonstrate to you. I'm using the xlock option to the open function. And this is going to give me an exclusive lock on the file that goes away when I close the file. However, I can't find in any manual pages that the close is explicitly going to close my exclusive lock. So I did a test to make sure it worked on OS X, but you may have to do an funlock on the file on different operating systems. There was no conclusive, it just made sense that that would happen, but there's no conclusive information on whether that works. So you'll see what I mean. So first I sanitize the path. That's cool. That works. Then here's where I do the open. So I need a file descriptor because it's classic Unix, not the, you know, the standard C fopen. And I pass it the option F. I want to write only. I want it to be created and exclusive lock. This means other child processes, if they try to open the same file, will be blocked by the operating system until this particular operation is unlocked. So I do that super quick. Then I use write, not fwrite, but plain old write, to write that file descriptor into there. Confirm that I wrote the correct amount. Then right away close the file. Now my experiment said closing the file gets rid of the exclusive lock. So there we go. That's it. Send a reply back. That's store. Now I need to include a few things. F control is one. Okay, once I've included F control, that all works, and I can sort of test out that. Cool, my test ran, and it made the file. And we can quickly look at what's in that file. And what you'll see, oh, I guess I don't. Okay. So now that I've got the load working, I just need to try, or the store working, I can now do load. Okay, so now what I'm doing is I'm going to change this function to do store load. That test function there can just test them both. Now normally I would say probably just test one component at a time, but when you have these paired components like typical CRUD operations, delete, update, read, they tend to have to work together anyways. And so like, for example, I can't really test load without testing create and store anyways. So just make them part of the script. Okay, that worked. And then, what is that? Exactly. So I'm storing I'm doing a storage. I wrote the file name. I created this file name. Why do I have junk? All my unit tests I wrote, the function names or the sanitized names came out great. That one comes out with garbage, which means I'm picking up random RAM. So there's chunks of memory out there. So I go back to my test. I know the logins path is the one that when stored caused that weirdness. See how I did that? So I run my test and then there we go. We have garbage. So this is reading past the end of functions. I'm clobbering something. I'm really messing this up somehow. So now I have to go into a debug mode. So the usual debug mode, I know it's going to be something in this stat server test. So first thing I'm going to do is print out each part one at a time. Make sure that I have okay, maybe this didn't come out as a multiple of the size of a uint32 times 2. So let's try that. And I'm using assert so it dies immediately. Okay, so that worked. So let's see. Let's go look and double checking that. That seems to be good. I'm kind of just glancing around. Okay, it's not the converter, but let's print this out real quick. Let's see what changing %d to %c at %d. So I'm getting the number that I'm changing in the original data and the character I'm expecting to be changed to and what index it's at. So I can see, okay, well, am I clobbering the end of the data? And I see, okay, so it's changing that to that and that to that. It gets to the end, but then I got this encrypted name. Okay, so I'm actually processing it correctly. I'm going through and converting it correctly. It's just the end is clobbered somehow. And then I see it. That right there. A 1 versus an I. That was the entire mistake. I had wrote the crypto out by looking at my notes. And if I did this 1, I would overwrite the end of the function and super clobberate. If I did I didn't. And that's the correctly encrypted name I have to use. That's how logins should be stored. So once I caught that error, the rest of this actually implements pretty quickly. I get that's encrypted. That looks more like, see how there's repeated U's and N's and stuff in there? That should have been a sign that these weren't being encrypted. All right, so remake the storage, come back over here, do a quick little create, a couple little things, do some samples, store it, flip back, close, and check it out. There it is. Nice. Take a look at the file real quick. All right, we got that. Now I need to do load. So there's load. So load is basically the inverse, and I'm making it so that if the target exists, it will overwrite it. So this is important because if I want to load is going from and to. So what I have to do is I have to do, like, let's say I want to load logins again after a client connects. Because remember, between client connections, none of the data from the previous connection or other clients exists. Once it's gone, once the client disconnects, its scratchpad disappears. So I have to do store. So I store logins. Now the next client comes in and it wants to load logins, but it should be able to load logins into logins, like, in its local RAM. So to do that, I have to allow me to overwrite them. Oh, and actually, I didn't even do it that way. I was planning to do it that way, and then I realized that that would be a problem. That's right. There we go. I didn't even do it that way. So instead, if 2 exists, I report exists. There we go. I was wrong. All right, here we are filling it in. I'm going to make a new record. I'm going to open the file for read only and open it locked using that exclusive lock. Then I'm going to read really quick and close it. So this is a good pattern. You want to just do the least amount of stuff you can between lock regions when you're trying to do multi-process processing. Because the more code you do between locked regions, the higher probability you'll do something that will block all the processing. All right, so I open the file. It's similar, but instead of write only, it's RD only exclusive lock, just like that. Okay. And, be more explicit, specific about your stuff. Wait, why did I put the B data there? Oh, interesting. Had a bug there. See that B data location doesn't have a matching pattern for it. Okay, make sure my cleanup does that. Oh, that was back in store, just to make sure. Because I realized I had a similar problem up in store from this one. Okay, so now we have read. That should load the same amount of data. Interestingly enough, if you had to move data to a new data structure, you would probably be kind of stuck. You would have to write a program that went through all of your data and converted it. Okay, so now I close that file descriptor. Copy the name because I'm creating it, so I had to calloc a name and the calloc of the stats. The stats just got written. Now I'm going back in. I create a new name for it with a copy, and I'm putting it in the hash map for the data, and that should work. Okay, doing some checks, getting things working. There was where that error with I had the no format string. I have a return code I didn't really use. I believe I get the to and from mixed up in this next part. Yeah, so I get rid of that from and I move it. I'm not sure exactly what I do. Yeah, I keep the from name. Yes, that was the mistake I made. I have to have a location to load. Oh, in the classic, I have to move the check down below. All right, that's all looking good. Now I do a load, add that to my store load test, and then I should be good. And then the way to test that that works if I do delete SAM. Okay, so that's the end of exercise 51B. That's all the hacking you get to see me do. I hope you enjoyed it.